was placed next to the F. Then thereafter, we are repeating step 3 and 4 until there is only one node. So here we have just a second. We are joining uh, like we already discussed H and U. Then we are joining M and N. So M and N are combined with 2, and it is shifted after H and U. So if any doubt, then please let me know. I'm checking the messages also. So 2 is nothing. 2 is nothing but the frequency. Like H is occurred one time, U is occurred one time. So total of H and U is 2, 1 and 1. If H was 3 and U were 5, so total frequency would be 8. So in the meanwhile, again in our next step, we have A and F. I'm annotating the screen and visualizing the things. I'm taking the pencil. So now we have where this 2 coming from. I'm changing the where this 2 coming from. We have frequency of M is 1 and frequency of N is 1. So total is 2. If M had a frequency like 5 and N has a frequency 5, then total could be of 10. But here we have only frequency 1 and 1, so it is 2. And we already have H and U, we already shown. Then 2, this 2 is coming after here, next to the this 2, because this is already placed. If suppose if this is not 2, this is like 5, then we had to shift this in between here, because F has a frequency 2. Now we have a frequency 2 that is shifted after. Like after every step, we are repeating the same step 1 and 2, because we are arranging in ascending order after each step. So here M and N has a frequency, total frequency 2. It is shifted here. I'm like discarding the drawings. Then we have in our next step, we have A and F. So A has frequency like 1 and F has a frequency 2. So what will be the total? The total will be 3. So where this 3 will be shifted? This 3 will be shifted after here. So we have 2 for H and U, 2 for M and N, and we have 3 for this A and F. In the next step that I'm going to share uh, after completing my drawings. So I'm moving forward the video and listen carefully.
Are now A and F, so we need to combine them. So the two frequencies, 1 plus 2 is 3, and then we have to reinsert this to our list. Now it's exactly the same. We've still got to combine our smallest 2 nodes. So we're kind of working at this level now. This is kind of a sub level. So we're now just looking at 2 and 2, so we've got to combine those. Our parent is going to be 4, and we still have the other one. And we need to order this. So 4 goes to the other side. We need to combine 3 and 4. 3 plus 4 is 7, and so we finally have a root node. We've only got one node. All the other.
So what we discussed, actually, we had I'm moving one step less. So this is what we had. We had H and U with frequency 2. We had M and N frequency 2, and now we have A and F frequency 3. So if we are combining and moving ahead, then we have this 2 and 2 is combined with the frequency 4, and we have A and F with a frequency 3. After this step, we are again moving in a ascending order. So in ascending order, A and F are with a frequency 3 is shifted to the left, and this 4 is shifted to the right because of ascending, like 3 is before 4. So in our next step, we have 3 is here and 4 is next to the 3. Then we are combining this 3 and 4 also, and we have a total 7. How we are placing this? We have a total of 3 and 4 is 7. Any doubt? I'm checking the messages one by one. If the original concept is still we are combining this tree. That confusion will be in the tree that you are combining. And if you have any doubt, then please let me know. I'm checking the video like messages one by one. Please raise your questions if you have any doubt. One student has a problem that voice was not there. Do we have a voice problem so far or now? Okay, that's fine. So till now, how this graph is generated, or sorry, this tree is generated, how this is generated? We had 3 steps. What was the first step? We were has a original frequency, like F has one, U has one, double F has two, M has one, A has one, N has one. After that, what we did? We did that in ascending order, in ascending order. From F was 2 in middle, it was shifted to the right, like in the same way as we were in the diagram.
Whole
Like
text file, but just repeat it twice.
it was shifted. Like this was the step one. We had all these frequencies written, and thereafter we had the second step. F is shifted to the right. This was the step two, and this step is repeated every time when we done the calculation. And in our next step, we did like start using H and U are combined. Then thereafter M and N are combined, which is two. This has two. Like from after this step, we are shifting this two to after F. Then we have M and N. We are shifting after this particular like two. So in the same way, we were doing like this. Then A and F had total of frequency 3. It is shifted to the next to the M and N. Then in the same way, we started for the next level, like 2 and 2 are 4. And thereafter, this 4 is shifted to the right. And then 3 and 4 will be 7 as so far. Okay, Uday is requested to play the video again. Okay, I'm start sharing the video from
With
this
our
place.
character and then the frequency in brackets, other way around is fine, just as long as you're consistent. So you need to basically show both the character and its frequency from the original text, like we've done here. Okay, so this isn't in order. You can see we've got F here, so we need to put it in ascending order, so the 2 goes to the end. And this is where the actual implementation can change depending on how you're actually going to code this, perhaps. So I've just shifted it to the end, but the order otherwise has stayed the same. You've got to kind of think how a sorting algorithm would do this, but this is an added complication. We don't have to worry too much when we're doing it by hand. So basically we've got our nodes separate but in ascending order. In this order, the first 2 nodes are H and U, so we need to then basically combine them and make a parent node. So we basically will draw this. So we've got H and U connected with a parent node, and this parent node hasn't got a character, but it's just got the combined frequency of its children. So 1 plus 1 is 2. And then we have our rest of our other nodes which haven't been joined yet. And basically we need to reinsert this back into our list. We've kind of taken this away and we need to put it back, making sure the order is the same. So 2 is now going to be compared to the other frequencies here. So again, we can kind of just put it to the end. We've now got 2 2s. But again, for kind of, if you put it in between A and F, your actual result would be different, but it would still be correct because of just the nature of this coding. But we'll talk about that in a bit later. So now we need to, again, just do a couple of repeats. So our first 2 nodes are M and N here, so we need to combine them and add their frequencies. Very similar, then reattach it to our list. The next two smallest nodes are now A and F, so we need to combine them. So the two frequencies, 1 plus 2 is 3, and then we have to reinsert this to our list. Now it's exactly the same, we've still got to combine our smallest two nodes, so we're kind of working at this level now. This is kind of a sub-level, so we're now just looking at 2 and 2, so we've got to combine those. Our parent is going to be 4, and we still have the other one, and we need to order this, so 4 goes to the other side. We need to combine 3 and 4. 3 plus 4 is 7, and so we finally have a root node. We've only got one node, all the other, well, we've only got one root node, all the others inherit from this. And a good way to check is that the top node should equal the total number of original characters. So we've got 7 characters in Huffman, we've got 7 here, so they do match, so that's good. And there is one final step which may be implicit depending on the implementation, but we need to label our arrows. And so we're going to say that the left arrow is going to be 0, and the right arrows are going to be 1. And it could be the other way around, it doesn't actually matter. The codes would just be the opposite, but convention is usually left is 0 and right is 1. So to actually get the codes here, you can see I've magically filled in this table.
So this is the last step of the like our coding. If the tree is generated successfully, after that we have to use the nomenclature in which left node has assigned as 0 and right edge is assigned as 1. So each time when we have a left node, we are marking 0 to the edge and we are marking to the 0 to the edge. For the right side, we have marking 1. 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 For all left sides, we have marking 0. And then we are putting this code after each character. Like first character was H. Where is H? H is here. So what is the root to reach the H? We have only single root. 1, 0, 0 is the root to use the H. What is the root for U? U is next to H. So U had only one root, that is 1, 0, 1, which is written as the code. Then we have F. So F has a node like 0 and 1. F had 0 and 1. M had like 1, 1, 0. A had is left to very left 0 and 0. And N had a 1, 1, 1. N is the most right one. Then the coding for is 1, 1, 1. So how we write this code? Like we are, instead of writing Hoffman, we are sending the message 100, 101, 01, 110, 00, 111. This could be the compressed code for Hoffman coding. And this compressed code is further decompressed into the Hoffman's exact numbering. So this is good for text messages that we are delivering. Any doubt in this? We are going to do one example as well as if you understand how exactly we did
We locate
this.
H on our tree and we go,
And you can easily visualize that if the frequency is more at the starting, like the largest frequency was for F. What was the frequency? F had a frequency 2, other than all other characters had a frequency 1. So if one character has a larger frequency, then it has a shorter code. Like if F had a frequency 10, then might be shorter. The code will be of 0, 1 or 0, 0, or it is reduced in length. And if uh, we have uh, less number of characters, by like we have X or like Z or W are very limited. So these characters had higher character codes like 10010 because of their less repetitions in the code. So I'm skipping a video for a second and
hello, this is going to be all about Huffman.
I'm moving to the this example, another example that we have. We already written the frequency of each character here. Like A had a frequency 5, B had a frequency 9, C had frequency 12, D had 13, E had 16, and F had 45. So F had a most number of frequency, like we arranged in ascending order. So F had a frequency 45. It means that F has the shortest code in term of uh, compression coding. So what will be the first step? First step will be write all the characters in ascending order, like we have A, B, C, D, E, F in ascending order. Then first we calculate, like if I'm she is saying that if we press 4, so computer divide into 111. No, 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 no. It doesn't meet 1111. Like I'm explaining this again with this particular example. So, from as per our video that we were playing, what we have to do, we have to start with like we are writing here. Uh, like I'm going to the blank space. We are like writing A5. You can also try to write in your notebook if you have like A5, B9. We have C12. It is easy to recognize. C12. We have D13, then E16, and F45. This is exact what we were writing in our example. So like I wrote like this. Is it okay? Any doubt? I think there is no doubt. Like this is step one. So what was the first step in that particular example? We were creating a node like combining this with this, and total will be 14. Is it okay? Total is 14. So where we place this 14? We will place this 14 after 13. So next, what will be the next frequency? Next frequency would be like this, like A5, if I'm not wrong, it is placed. So we will have A and B, we are already cancelled. Then we have C12, D13, and now we have a 14. 14 as a new frequency that is coming with A and B. We can write like A and B, we can understand in later. And we have E16 and F45. Or we also can write like this. This 14 is coming from A and B. A had 5 and B had 9. Any doubt so far? In the same way. So next will turn will be of C and D. So C and D means if we are calculating, this total will be 25. Please let me know if you have any doubt. Then where this 25 will be placed? This 25 will be placed after 16. So then here we have a 14, here we have E had a 16, and here we come with 45. Then 45 had a C and a D. Any doubt? Then E had 45. The next combination would be uh, 14 and 16, that is AB and E. So 14 and 16 would be like if we are calculating here, like we have a 14, this is 16, this is 14, and total would be 30. And after combining, we would have a exact scenario like uh, it is like kitna bana 30 bana na? So we have 30. So 30 means this is moving 25. 25 is done. Sorry, 25 is not done. So we have 30. Like so we have 25 first, then we have 30, then we have 45. These are the frequency. So 14 is done. Then we have 25 is coming from C and D, and 30 is coming from like A, B, and E. So the total will be 55. So if the combining of 25 plus 30 is 45, 55, then it is moving after this 45. So after that we combine like 45 and 55. Total would be 100. And we can match that total, that whatever the total is coming, that total is always matching with these. What will be the five, the frequency? 5 plus 9 is 14, plus 12 is 26, plus 13 is 39, and 16 is equal to 55, and 45 is 100. So this 100 would always be matching the total of all frequencies. So if this 100 is matching, we are again going for the left and right. For left, we are going with 0. For right, we are going with 1. We have 0 for left, we have right, 1 for right. So 0, 1, 0, 1, 0, 1. So what will be the frequency for F? Can anyone tell me with this particular diagram, what will be the frequency of F? Please let me know. I'm asking. The diagram is there. Provide the frequency. F would have a frequency 0 as it is on the leftmost side. So, and here, oh, sorry, F had a frequency 45, but now the compression code for F is 0, because if higher the code, less the compression code. And for C, what will be the frequency? For C, we have a frequency 100. For D, we have a frequency 101. For A, we have a frequency 1100. For B, we have a frequency 1101. And for E, we have a frequency 111. So please let me know who has the most number of characters, like most number of digits uh, as a compression code. Out of A, B, C, D, E, which has the higher compression code. You can easily check that A have a frequency 1100 and B have a frequency 1101. And you can check that these two had lower number of frequencies. Like A had frequency 5 and B had a frequency 9. And so it is proven that if we have less number of frequency in a particular string, then that could have a more number of compression digits in that compression code. So a if anyone had a less frequency like A, so before A could be Z, Z has a frequency 2, so it could have a higher code irrespective of A, B, C, D, E. This is the simplest technique used for the compression. I hope you understand. So you all have a homework. Homework is what you have to solve two Hoffman codings. One is for your name and one is for any of your like family members' name, your brother, sister, or like father or mother. Uh, if more the numbers are like larger the name, we would have more like more repetitions are there, and we will uh, check that in our next session at the starting. So please prepare that and discuss for your name, like you can have a message, then can you write on your chat box, and I will check that you have a correct options. And might be possible we have an option to share the image. I don't know in this particular has, if has an option to share the image in chat box, then you can click the photo and can share with me the image. So I hope everyone is fully satisfied with this particular. Then we can have several advantages of using Hoffman coding. The first is optimal compression frequency. We have lossless compression. We have prefix free codes. So no code is a prefix of another. So all are the unique codes. No one has the repetition. Like here also, we are not saying that any of the code is repeating. If D has 111, no other character has a code 111 because it is a unique way to represent. The next is adaptive to different data types and simple and faster implementation. It is the most easiest way to implement Hoffman coding. Okay, that's fine. Then I'm moving forward to the Shannon-Fano algorithm. I'm not going to discuss any like theoretical information so far. I'm just pitching you a video. Then we will discuss. So listen carefully. I'm not stopping the video in between. I will stop in the second time.
In this presentation we are going to look at Shannon-Fano coding. So let's look at an example here. Suppose we have a 6-symbol alphabet where the probability of each symbol is tabulated there. So the probability of symbol A 0.30, symbol B 0.25, and so on. What we're going to do is sort of set it up like this. We have a column there for each of the stages we're going to go through. At each stage what we're going to do is partition the set of symbols. Now, I sort of have the example in front of me, so I know there's going to be 4 stages, so you wouldn't know that in advance. So, what we're going to do first off is we have to partition our set of symbols, and how we, according to the idea that the sets must be as close in terms of probability as possible. So that means as equiprobable as possible. So we're going to partition it here. 0.55, which is the sum of the probabilities of A and B, and 0.45, which is the sum of the probabilities below. That's as close as we can get to equal probability. So, for everything above the partition, 0, 0, and everything below the partition, 1. Okay? So that's, each stage goes like that. Now, in this stage, in this next phase, we have A and B. There's only one way we can partition A and B, because there's only 2 symbols left. So 0 and 1. That in that case is sort of straightforward enough. Okay. We're finished with A because there's no way we can there's no way we can partition it anymore. The symbols we have is 0 and 0. So the 0 there and the 0 there. The partition, the symbols for B, 0 and 1, because that's it, finished now. So below the partition, that main partition there, What we're going to do is have to split the C, D, E, and F into two equal groups. So let's do it here. Now if you look at it, that everything above this partition, 0.20, and everything below it, 0.25. If you try around it a few different combinations, you'll find that that's as close you can get as you can get to equal probability between the two subgroups. So everything above this partition, 0. Everything below it, 1. So the partition is there. And again, you can see that C is now finished. It is coded as 1 and 0. Now, D, E, and F. Let's partition this up. So we'll partition it here. 0.12 above, 0.13 below, 0, 1 and 1. D is finished. It is 1, 1, 0. There's only one way we can partition the remaining set E and F here. So 0 and 1. So E is coded as 1110. F is coded as 1111. And that ends our presentation. So looking at it again, that's how we would code it there. And
So this is the extract of Shannon-Fano coding. As we are running behind the time, so I'm not going to discuss the details. What exactly is Shannon-Fano coding? What are the advantages? What are the disadvantages? What are the ways to perform it? But I'm just uh, providing you a numerical abstance how we are doing. We have some characters with some probability. Probability means we have the occurrence of the probability of occurrence of A is 0.30. We have a probability of occurrence of B is 0.25. Lesser the probability, it means the repetition of that character is limited. If higher the probability, it means that character has more chances to repeat in that particular string. So if A has a higher chance, like which one is better? 0.30 is better or 0.05 is better? Yes. I'm asking a simple probability question. The homework is very simple, Shiv. We just need to do the Hoffman coding for our name and one of our family members' name or a friend's name. Just two questions of Hoffman coding that if we have like I have a name Ashwini. So how many A's are there? How many S are there? How many H are there? How many I are there? How many N are there? So I have to arrange them in like ascending order first, and then we'll create a map and marking 0 to the left and 1 to the right is the simplest way. And then I identify how many characters are used for A, how many characters are used for S, then H, then I, then N. Is it okay? You may write somewhere if you forgot like me. So this is our Shannon Fano where we have probability given, and there is no concept of ascending or descending order. We are writing the probabilities, occurrence probability as it is in this particular table. Then we have what is the next step? Next step is the total of these is total of these probability is like 100. That might be 100, like because probability always comes out of 100. So we have 0.3025 8 and 5. So total is 100. So what we are doing, we are trying to divide all these in equal probability. Equal probability means or near to equal. Like the uh, the 50-50 of like 100. Equal means 100 is divided into two parts. It means 50-50. But that is not possible because we sometimes we can have a 52-48. We can have 47, 53, or like nearest one, whatever the nearest one is, like 45-55. So here we have we divided this particular uh, marking into here. So how we divided this? The total of 30 and 25 is 55, and the rest of have a total 45. Is it okay? If we mark here, then the total is more higher than the total of these. I hope you are understanding. If we are combining plus 20, it would be 65, like 75, and now it will be 25. So 75-25 is not the equal one, but 55-45 are the near to equal. So we are dividing in 45 and 25, like 55 and 45. So the upper portion, whatever the where we marking, we are writing 0 and 0 here, and all lower are marked as 1 and 1 at the bottom. This is the first step, and we will move with all steps. Second stage is like we already divided here. So we are going with A and B. So how we divide A and B? Only one option is there. We divide A to the upper side and B to the lower side. So if A is at the upper side, we have 0 for A and 1 for B. I think there is no doubt. Then the lower one was there. So we had C, D, E, F. So 20 and 12 has a total of 32, and 8 and 5 has a total of 13, which is like very different. 32 and 13 is not the equal. So what we are doing, we are marking here. So here we have a 20 at one side, and like 13 and 20, like 25 at the other side. This is near to equal. So if uh, 20 and 25, so for the upper side, it is the 0, only C, and for all at the lower side, we have 1, 1 for the all. Then we cannot divide A further, so nothing is here. We cannot divide B, nothing is here. We cannot divide C, nothing is here. We have D, E, and F. So only one possibility is there. D has a total 12, and E and F had a total 13. So 12 and 13 are nearly equal. So D is on the upper side. It is marked as 0. E and F are on the lower side. They are marked as 1, 1. And in the same way, again, E and F are further divided. So there is only one possibility to divide E and F. E is on the upper side and F is on the lower side. E has a parking like probability 0, and F has a probability 1. So but nothing, we just are calculating these zeros and ones. So A had 0, 0 twice, so we are marking as. B had 0, 1, 0, 1 marked as. C had 1, 0 marked as. We have E, like D, we have 1, 1, 0, then 1, 1, 1, 0, and F had 1, 1, 1, 1. So they marked as the code. This might be less complicated than the Hoffman, but once you are comfortable with Hoffman, you will write the Hoffman code in your fingertips. There is no table required in Hoffman, but you have to create a tree. Here, no tree is required. You just need to create a table. We are over for the time for today's lecture. If you have any problem, you can like take a screenshot of this particular screen, like taking it blank. And you can try for some another question. I will give you a couple of questions for Hoffman and Shannon Fano. Then I will discuss adaptive Hoffman coding as well as in our next session. Any doubt so far for these two? Please let me know. Then I'm wrapping up the session. So thank you guys. If you have any doubt, you can also raise your question in our next session for the next week, and we will discuss if you have any problems or you have any doubts in any of these two. So thank you for today's session. Have a good day.